So for today, we are talking about graphing proportional relationships. All right, and so this first one says, what is the unit rate for Fred's sub shop? So I've given us two lines here so that we can practice this more than once. But when you see the word unit rate, you're trying to figure out for every one unit what happens, or what is the rate for every one unit. So if we look at the blue line, if we try to find the unit rate, we don't just see the points that it gives us. Sometimes we can use the points it gives us, but really what we have to figure out is what's going on for every one thing. And in this case, we're talking about the number of subs. So the unit rate here would be, what's the rate for one sub sandwich? So if we look over here, we want to know just how much it is for one. So like our number of subs, we have 0, then 1, then 2, then 3, 4, 5, 6, 7, 8, 9. If we want to know what the price is or the rate for just one sub is, we would find 1 on the X and we would follow it up to the cost. And in this case, the unit rate would be $10 per one sandwich. So the unit rate here is 10. Let's practice that again with the red one. If we wanted to find the unit rate for the red line, we wouldn't go over here and we wouldn't say that it's $5 for 2 subs. That's not a unit rate. We want to know how much it is for one sub. I should have filled in the rest of this axis too. So this is 5, 10, 15, 20, 25. Okay. So if we want to know the price of just one sub, you could use this point and you could say that it's $5 for 2 subs. And you could do the rise over run. So $5, rise up 5 over 2. But you have to reduce that. When we do unit rate, we want to know what it is per one thing. So 5 over 2 is the same thing as $2.50 per one. Like if you put, there's two ways to look at this. You can look at it right here on the graph. For one sub, you go up halfway, which is $2.50, or you could put it in Desmos. Let me pull up my calculator. And you could type in 5 divided by 2, and again, it tells you that that's $2.50. So the unit rate here is not 5 over 2. The unit rate here would be $2.50 per one sub sandwich. Okay, what is the slope-intercept form? So we're going to do two lines again. We're going to practice this twice. First of all, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so if we go try to do this for the blue line, there's two things we have to find. First, we have to find the slope, which is rise over run when we look at a graph. So if we start down here at the bottom and we rise up and run over, we rise up 10. I know sometimes it looks like 2 because you rise up 2 spaces, but you got to look at how the graph is labeled. And here, if we rise up, it says that we go up 10. So we rise 10 and then we run over 1, and that's not labeled there, but we go 0, 1, 2, 3, and so on. So here our slope would be 10 over 1. And then to find the y-intercept, it's wherever it crosses the y-axis. Let me go ahead and highlight the y-axis. This is our y-axis right here. And our blue line for the sub shop, if we look, it crosses the y-axis right here at 0, 0. So my y-intercept is 0. And so then if I go to plug these into my slope-intercept form, I'm going to have y equals, my m is 10. You can put 10 over 1 if you want to. You don't have to. My y-intercept is plus 0, but usually we don't put the plus 0 on the end. Anytime you're adding 0, you can just get rid of it. So I'm going to shorten this and say y equals 10x. That is my slope-intercept form for the blue line. Now let's practice that again for the red line. Again, we have to have the slope and we have to have the y-intercept. So for our slope, if we start at the bottom point, we rise up and we run over, we actually rise up 5, right? Because it goes 5, 10, 15, 20, 25. So we rise up 5 and we run over 2. So our slope is 5 over 2. And our y-intercept where it crosses the y-axis is also down here at 0. So if we go to write this, we would write y equals 5 over 2x plus 0, but we do not have to have the plus 0 in there, so I'm going to go ahead and get rid of it. Most of the times you'll see the slope left as a fraction, but sometimes in real world problems like this, it makes more sense to turn the slope into money since we're talking about money. So they may go in and divide at 5 over 2 and say that that's $2.50. So they may rewrite this as y equals $2.50 x. That either one of these would work. And you could have the 0 on this or not. It's up to you. Okay. What is the slope of the line for the cost of the sub shop at Sam's sub shop? All right, well, if you're thinking about slope, you got to think about rise over run, but this one's a little bit tricky because it doesn't just give you an X, Y, T table. You have to go back and think about how the graph was labeled. Remember in our graph, the y-axis was the cost and the x-axis was the number of subs. Like if we go back and look at these other graphs, the number of subs is the x-axis and the cost is the y-axis. So this isn't written as an X, Y, T table because the cost is not the X value. The cost is actually the Y value. And then the number of subs is actually the X value. That kind of bothered me a little bit when I first looked at it. If we wanted to find the slope of this line, you don't have to graph it. But I wanted to show you what it looked like to graph. If you bought 0 subs, it would cost $0. If you bought 2 subs, let me go out here to 2 subs, 1, 2, it would cost $11. I don't know exactly how we want to do this. Let's do 5. Let's do it like the last graph. 5, 10, 15. So 2 subs would be right here above 10 at $11. So that's what our line's going to look like. And then to find the slope of the line, you do rise over run. So you're going to rise up $11 and you're going to run over 2 subs. So my slope would be 11 over 2. Now, since it's a real-world problem, usually we leave slope as a fraction, but since it's a real-world problem, they might turn that into money. So if you needed to turn it into a decimal or into money, you would say, oops, go away. You would say 11 divided by 2. So it's $5.50 per sub. So the unit rate here is $5.50 per sub. So there we go. The slope is 11 over 2 or 5.5. The equation for the cost of subs at Annie's restaurant is y equals 3.5x. If the cost of the subs at all 3 shops were graphed, which would have the steepest line? So if we have an equation y equals 3.5x, the number attached to x is the slope. So in Annie's restaurant, we know that the slope is 3.5, which means that the unit rate or the cost of subs is $3.50 per sub. So if we think back, remember I did change the numbers, so let's go back. Let's use the blue one where 1 sub was $10 at Sam's. I mean, not Sam's, what was that? Fred's. So I'm going to use the blue line there. I'm going to use this here for Sam, 5.5, and then 3.5. So if Fred's was $10 per sub, and Sam's was 5.5 per sub, and Annie's was 3.5 per sub. Goodness, I'm having a hard time talking. The steepest line, the one that's the most expensive or the one that goes up the fastest, like if you think about the price rising up the fastest, would be Fred's. That would be the steepest line. For every 1 sub, Fred's goes up $10. For every 1 sub here, this goes up $5.50, and for every 1 sub here, it goes up $3.50. So 10 is going to be the steepest. All right, Eddie and her family traveled from their house to another city for several hours. On their way to the city, Eddie recorded the distance they had arrived, as shown in the following table. When they traveled back home, she wrote the following function that gives the distance they covered over time as y equals 47.5x, where y is the distance in miles and x is the time in hours. In which part of the trip did they travel faster, going to the city or returning home, and what was their speed? Okay. We know the speed for returning home. When they give you slope-intercept form, remember that the number attached to x is the slope. So in this case, that is the speed, the rate of change. So coming home, returning home, they were going 47.5 miles per hour. So for every hour, they would go about 47.5 miles. So let's check how fast they went there. From 0 to 57. Oh, wait, this goes by 2 hours. Okay, so that does make it a tiny bit more complicated because it doesn't go by every 1 hour. So what we can do is we can just reduce it each time. So they went 57 miles in 2 hours. So if we did that in our calculator, 57 divided by 2, oops, I typed that in wrong. For each of those 2 hours, they were going 28.5 miles per hour. And then let's keep checking it to see what happens next. From here to here in 2 hours, they go, let's see, what is 171 minus 114? 57 again. Let me check and make sure this is the same too. 228 minus 171. So they're going every 2 hours, they are going 57 miles. Remember, this goes back to the arithmetic sequences when we found common differences. We're finding how we got from one to the next by subtracting. So our common difference is 57. So every 2 hours, they travel 57 miles, which means that they're going 28.5 miles per hour. So if we want to know which one's the fastest, coming home was faster. Let's see what our answer options are. Going to the city at 57 miles per hour. So they're not going at 57 miles per hour, and this is what's tricky here, is the time is not going by 1 hour each time. If this had said 0, then 1, then 2, then 3, then 4, then yes, it would be 57 miles per hour, but that's not what it says. It says every 2 hours. Going to the city at a speed of 28.5 miles per hour. Well, that is how fast that they went to the city, but it says in which part of the trip did they travel faster? And they did not travel faster going to the city. They traveled faster coming home. Because when they came home, they were going 47.5 miles per hour. They were not going 95 miles per hour. That would be crazy. So this is your answer. When returning home, they had a speed of 47.5 miles per hour. I think that's it. Yep. All right. I hope this helps.